Hey, g'day, it's Prezone. Thanks for stopping by. Now, welcome back to Thread Express. But as you can see, Thread Express is completely disassembled at the moment on the bench here because I'm taking care of a few loose ends, things that I've put off until now that weren't terribly important to prove the build, but they have to be done. So I'm taking care of those issues at the moment. I'll show you a few of the updates and improvements before we move on to the main topic of today's video, which is making the fly cutters that go with Thread Express so you can mill threads on the milling machine. However, my wife and I just returned from a 10-day break in Sydney. We went down there to meet up with some family, and on the way back we called in to see John Creasey. Now, John has an excellent YouTube channel, and he lives in Sydney, just north of Sydney CBD. And we're on our way back home, so we called in to see him. And I want to show you a little video that I shot while I was there, just showing you around his workshop. Now, he's got this lovely compact workshop, but it's full of beautiful tools, and not one but two Myford lathes. So let's have a quick look at his workshop tour, and we'll come back to Thread Express. Okay, I'm here today with John Creasey, and we're down in Sydney, and we're visiting his workshop, and he's going to do a walk around. All right. And show us what you got.
Welcome to the workshop. As I always say, we've got the this is the heart and soul of the workshop, the old Myford Super 7, and all the stuff ready to go. We've got cabinets and the surface plate, tool grinder, got the milling machine here, and that gets a lot of use. And this is my ML7, which is the first lathe I ever had.
Yeah, John's one of these lucky souls that has two lathes.
Yes, that's right. So I got this when I was 16.
And you said you bought that brand new.
Brand new. So
all right, so share with us.
All the damage is my fault.
So how much would you have paid for that back in what, 1920 or whatever it was that you?
No. I think it was probably about $1,000, something like that. I've got the invoice somewhere. It's had a few changes. I've added the Hemingway depth stop, which is really good, and this is a new tailstock. Not a new tailstock, but it didn't come with this tailstock, but it's got this what do you call it, rack and pinion.
So where would you source something like that?
eBay.
Okay.
Yeah. A guy on eBay was selling it, and I bit his arm off trying to get there first because I knew what it was, and I've never seen another one come up. But
that DRO is really unique. I don't think I've ever seen one like that.
That's a Hare and Forbes special. They don't sell them anymore, and ideal for the Myford because it's one of these magnetic ones.
Okay.
And the trouble with the Myford is generally people will put a big aluminium glass scale, and it comes right out to here, and it's very unsightly. And this one is just tucked under there, very unobtrusive. And there's another one on the back here for the Y.
It's very compact.
Or the X, actually. I think that is the X. No, that's the Z.
Love these things too.
Yeah, the secret with these, which I always tell people, is never turn them off. Set them up and then put some oil in when you use the lathe, and then if you come to use the lathe and there's oil left in there, you know that they're not working. But otherwise you tend to you just always forget to turn them off anyway, and people generally, you'll see they've got a lovely Myford lathe and these things are full right up to the top, and you know they never use them.
So will that, if you don't use the lathe for say 2 weeks, will that just drain through?
Yep. Usually quicker than that. So I just put a squirt of oil in and just let it do its thing, and then do that when I'm using the lathe.
Okay.
This is the standard storage position for the Myford. Has a little tiny Allen key, and the back gears for a Myford. This is probably a bit inside baseball, but the back gears for a Myford, you use this little Allen key to release that little hex bolt, and that slides out like that.
Okay.
And you tighten that off, and then you can put the back gears in.
That just
like
separates that
yeah,
gear from the
yeah,
shaft.
Yeah. So that disconnects this one from this one,
Yep.
and then the back gears will work
Right.
like that, and then you can see that it gives you a speed reduction. Modern lathes don't have back gears, and that's the benefit. And if I want to do a thread cutting, I have to, for this lathe, I have to set up all the change wheels,
Yep.
which is always fun. And for the other one, I have a gearbox. Anyway, this is moving on with the tour. This is my compressor down there.
Okay.
Shouldn't really be under that, but a nice quiet compressor.
Yeah, I've got one of them. That's a Chicago one.
Yeah, fantastic. This is all my taps.
Wow.
And I got a BA metric, BSB, model engineer, and BSF, UNF, and Whitworth is the worst.
You make that?
No, that's
Okay.
on Amazon.
So tell us about this, John.
Oh yes, this is this is a work in progress, and viewers of my channel would be familiar that I've been building this, and I'm overdue for a video.
You're awaiting inspiration.
Yeah, the thing is, I filmed all the bit to get, done all the film to get this bit to this stage, and I just need to put it all together and make a video. And in the meantime, I've been procrastinating, and I've put in all this these air lines around the workshop, and I've got another video that I've got to finish for that before I do this one. So it's all backed up, and then my wife's had me painting the house.
Okay.
Anyway, so this is the metal bender.
Oh yeah.
It's a nice tool.
Is that the 600 wide one?
Yeah.
Right, because I've just done a video on sheet metal, and I was sort of saying that I might get one of these.
Oh
and,
yeah, it's pretty good.
Yeah. So their capacity is about 1 millimeter in that width.
Yeah, depending
steel.
on the metal.
Yeah.
You can get away with a bit more in aluminium,
Mm.
but you've got to be, you don't want to push it because they're easy to bend.
Yeah.
You know. And I do a bit of sewing, so I made my own covers for things.
Cool.
And they make all the difference, keeping the moisture out. It's shears.
Yep.
Just keep them covered. This is the bench where I do my brazing and whatever else, and this is my my little steam plant. Yeah, can we?
Yeah, we had this running on air.
There we go.
Okay. Can I do this?
Yep. We haven't got the compressor's off now, so we only have a little bit of air in the tank. But that's the thing, and then there's this little hammer here.
Yep.
There we go.
Lovely.
Yeah. There's some videos on my channel of all of this stuff. If anyone's interested. I've got a sign from the famous Emma.
Oh,
Ritson.
that's Emma's stuff. Yeah.
Yeah, a handmade sign and other various projects
Mm.
from the time, and yeah, that's about it really.
I got to say, when you watch YouTube videos and you look at people in the workshop, and they always look enormous, and then you sort of see them up close, and yeah, I mean it's a wonderful space.
Yeah.
I love it. A lot of atmosphere.
There's no room for anything much more though.
Yeah.
You know.
And this is the thing that I want here.
Oh yeah, surface grinder. I'm lucky to have this.
Yeah.
This is kind of a big boy's tool.
That's it. Yeah.
Whatever move, I'm gonna have fun.
Yeah, I think you've got to have one of these to be taken seriously.
Yeah.
All right. Thanks very much for showing us around, John.
Been a pleasure, Mark.
Yeah, and it's lovely to call in and meet a fellow YouTuber.
Yes.
Yeah. Now, I must thank John for his hospitality. It was wonderful to catch up and have a look around his beautiful workshop. Now, he absolutely guaranteed me that he hadn't cleaned up specifically before my visit, which is what I always do if anybody comes to visit me. But yeah, it was wonderful to look at a lot of his projects, ongoing projects, one of which is a Stewart steam engine. and also the beautiful little steam plant that he has. Now, I'll put a link to his YouTube channel in the description of this video. There's also one up above there now on the screen. Now, John loves doing model engineering projects and also tool making, so check out his channel. He does some absolutely awesome stuff. Now, let's get back on at Threadexpress. I want to show you a couple of the upgrades and a few of the last minute jobs, and then we'll get on and make the fly cutters. This is one job that I hadn't completed when I made the lead screw for Threadexpress, and that was to fit this M6 socket head grub screw that engages in a countersink just underneath the M40 thread. Now, it's a bit tricky. What you need to be able to do is drill through the boss on the back plate and just make a mark on the actual spindle, and then you need to drill the countersink so that when you tighten the grub screw, it has the effect of actually tightening the thread on the back plate against this sort of boss here. And the difference is only about 2 degrees, but you can see when you tighten this up and drive that all the way in and then lock the grub screw, you can see it actually just cinching up that threaded connection there. And that ensures that there's no way that the chuck can come loose when you're doing any of the thread milling operations. In the previous episode when I made these sheet metal covers, and these keep the chips out of the mechanism of Threadexpress, I put a single rib nut in this location here, and you can drive an M4 socket head cap screw into that rib nut, and that keeps that section of this removable cover in place. But I did mention that it was a bit untidy down here, that there was nothing securing this end of this removable chip cover to the fixed chip cover on top. I talked about putting a magnet in there, but in the end I used a sort of tab and slot arrangement instead. So you can see there that there's a little tab which has been spot welded to the outside of that cover, and then there's a matching slotted plate that's been spot welded on the inside of the cover there, and that allows you to just simply slide that little tab up in place, and that keeps that secure, but it's easy to remove. So that's done now, and these covers need to be sandblasted and powder coated, and I am going to fill the gaps around these joints here with probably JB Weld, sand it off smooth and powder coat that, and it will just look absolutely seamless. One of the last parts I've had to make for Threadexpress is this flexible chip cover. Now, it covers up the gap between the main sheet metal cover and the main slide plate. And in thread milling, there's a lot of very small chips that are formed, and you don't want any of those getting caught in this gap here. Now, this is made of EPDM rubber. It's a synthetic rubber commonly used for pond liners. That's where I actually got this from. It's leftovers from a pond that we installed. It's 1.6 millimeters thick, and it's very flexible and stretchy, and it's oil and solvent resistant. It's also relatively heat resistant, or at least the heat caused by the small chips, and it's going to get anchored to the sheet metal cover with 3 holes that are punched through that sheet there, and there will be 2 pieces that anchor that to the sheet metal cover. Now, this is a 3D printed part, and this is just a thin aluminium strip that goes on top of that, and that will get installed there, and then the free end of that cover will get trapped between those 2 parts there. And at the top there's 2 more strips of aluminium that are screwed into threaded holes in the main slide plate. Now, check the operation of this, and when you advance the headstock all the way up, it doesn't come into contact with that, so that should be fine. Now, there you go, that's the flexible chip cover, and like I say, get leather if you can. To make the fly cutter for Threadexpress, and this is the one for cutting external threads, I've got a 100mm long piece of 16mm precision ground semi-hardened steel rod. Now, this is the type of stuff you buy for making linear rails on CNC machines, so it's got an induction hardened skin on the outside. Now, you can cut it with carbide tools, but getting through that skin is a bit tough. But the good thing about this is that it's very stiff, and being precision ground, it'll fit in a collet really well. So I've got a square collet block in the vise here. I've set that over to 45 degrees with the digital angle gauge, and we'll just clamp this in the collet, and then we need to cut a flat on top and a vertical flat on this right hand edge here. Now, I've done a drawing of this. It'll be released in the drawing package along with all the other parts at Threadexpress, and I've just duplicated the one that Cliff Hall has made for his machine. and he's got a video on making the fly cutters, and I think he'll be releasing that soon. But we'll go ahead and get this clamped up, and it's a pretty straightforward job. We just need to drill and ream for a round high-speed steel 6mm tool bit. This will be ground on the D-bit cutter to make the cutting edges. Now carbide is preferable, but I don't have any. I've ordered some, but we're going to use this to start with. Now before I start, I want to find the centre in Y so that when I drill and ream for the high-speed steel tool bit, it'll be centred on the axis of the cutter. So I'm using this because it's easy. You can just sort of touch off on one edge, you can just lift it up, move over to the other edge, put it back down again without moving the spindle in Z or in X. So I'm just visually putting that ball in the center of the stock here. Doesn't need to be perfect. When I touch off on this edge, I can just sort of move it around the other side. Alrighty, that's my centre in Y, so I've set that on the DRO, so I'll go ahead now and cut the two flats so we can come back to that centre to drill the holes. Okay, so this flat here needs to have a reamed 6mm hole going right through to the other side, and then when I flip it over I've got to drill and tap for M5 on the other flat there. Now they need to be centered in Y so they intersect the axis of the stock. The exact distance from this flat here is not that critical, so I think I'm just going to eyeball it. I have got a dimension on the drawing, but yeah, I'm not sure it's that important. It's about 1/8 of an inch or 3.2mm. Okay, I'm set up in Y and I've offset around about 3.2. I've just realised it's going to be a bit tough on my poor old high-speed steel drill bit. It's going to intersect the hardened skin on this material. So yeah, we'll just have to hope for the best there. I don't want to destroy my good drill bit. In hindsight, this was the wrong material to use. I should have just got some unhardened silver steel or drill rod. That's precision ground and you can drill and work on that without a problem, and then if you really need to you can harden and temper it later. Anyway, see what happens. Yeah, I can feel that drill bit coming up against the hardened skin on the other side there, so I'm not sure I can go any further there. We've got enough engagement for the tool bit though, so I'll go ahead and ream that, but again, probably going to damage my reamer. Okay, that's pretty much it. That drill bit I just put through there went inside that hardened skin, and you can see that it's about 2 to 3 millimeters thick around the outside there, and luckily my drill and tap didn't have to go through that, but there was no way I was going to get that 6 millimeter or 5.8 millimeter bit right out through the other side here, through that hardened skin. So I think it's going to be okay. I will have to cut the tool bit to length to make sure that I still get enough engagement out the side here. But we'll do that now. We'll go ahead and grind up the tool bit and fit a grub screw, and we're pretty much done. So this is a top view of the tool bit that we need to create here. So first job is to grind half the thickness of the stock away. So 6mm diameter, take 3 millimeters off the top, and then we've got to cut this 60-degree protruding cutting edge here. But it's got to be done at 2 odd angles. So the first flank is 75 degrees to the axis, and the second flank is 15 degrees to the axis. And that will offset the point of the cutting bit so that we can cut right up to a shoulder. So I've got set up in the collet here now, and we'll go ahead and just take 3 millimeters of stock off that diameter. I think I need to dress that wheel. Okay, close enough. I've swiveled the workhead round at 75 degrees now from where it was when we cut the flat. I've rotated the workhead round 90 degrees to put the flat on top now, and I've dropped the workhead 8 degrees, so I've got 8 degrees of front clearance on the tool bit. So I just need to grind a short flat there. The exact distance depends on the size of thread that you want to cut. Now the first thread I'm going to cut is only an M5 I think, or might be M4, so I don't need a lot of cutting edge on that. Most of the clearance is going to be done on the back. So I'll just cut flat about probably 2 millimeters wide. That should be ample. Okay, I think that's ample for what I want to do. The bulk of the material will come off this back corner here, so I'll reposition for that cut. Okay, that's sort of right. If I go any further with this grind I've just done here, I'm going to take off all of the cutting edge. It's just going to break. But my first flat didn't go far enough. It's not creating the point that I need, the 60-degree point. So I just put the drawing back over the top of the tool bit to check everything. And yeah, I can see that I didn't go far enough with that first flat. So it's a bit of a compromise really in order to get the angle that you want so you can cut right up to a shoulder. You have got to take a lot of material out of the back of the tool bit there. But I think that's about as far as I dare to go with that. So we'll go back and do the first bit again. Okay, that looks right now. I do need to check the angle with a threading gauge, but we'll do that. Might need to just touch it up a bit. I'll cut this off to length and then we'll insert it into our fly cutter bar and see how it goes. Okay, just as a bit of a sanity check, I've set this up on the bench here, and you can see the tool tip that would cut the 60-degree V in the thread there. And this is an M10 bolt, but you can see that this little corner here is going to get in the way when we start doing much smaller threads, and the very first thread I want to cut is quite a small one. But I can grind a bit of that point away there without affecting the performance of the tool, so that's probably what I'll do. So there's an overall view of the whole thing, but it's all upside down. You have to imagine that this is going to be up in the spindle of the milling machine when we're operating Threadexpress, but just gives you a better view of what's happening down there where the shoulder is. Okay, that's all I'm going to do on this today. That's all I wanted to show you, but I have been doing some work on other parts of Threadexpress. So I've done all of the powder coating, I've done all of the parkerising, and I'm just about to start on the anodising of the parts, and then everything goes back together. So I'll show you some of the parts, and just so you can see where we're at, and then we'll finish up for today. So here's the steel parts that I've parkerised. There aren't very many. These are all on the outside of Threadexpress. The parts that are inside the headstock, I'm not going to worry about those. I have actually done the chuck backplate as well. But these parts have just come out of the oil yesterday, so they're still a bit oily. That'll dry off in the next couple of days. But yeah, parkerized finish is beautiful. I reckon it's sort of way more durable than a cold blue that you might use. It's highly rust resistant, and it just looks nice and it feels nice. And the textured surface carries the oil. And for parts that need to slide, like these parts here, it means that you can just lubricate it once and it will hold that oil film. And of course, the rust preventative properties of parkerizing are legendary, in my view. Well, I'll show you something. These are some sample parts that I did about, I think it was about 6 years ago. And these just sit on a shelf in my workshop, and I don't touch them. I just come back every now and then and have a look. Now, this is a sample of mild steel that was completely untreated. That's my sort of control sample, if you like. And these 1, 2, 3, 4, 5 here were all parkerized, and they had different treatments after the parkerizing. So some were just sprayed with WD-40, some went into the parkerizing dry touch oil. I think one of them was just not treated at all, but these have remained absolutely perfect. There's no rust on the back of that. What you're seeing there is just dust from being on the shelf. But yeah, that's just nearly 5 to 6 years sitting in the open, and I don't touch them. So that's how good parkerizing is in terms of preventing corrosion. These parts here were zinc plated, and that one was just done with a blue chromate finish, and this one had the gold chromate finish. And also they are completely unaffected by rust. So that's why I get into this treatment, or surface treatments for steel. In my workshop at least, I've got to be really careful about rust. And I don't know if you caught Dan Gelbart's video that came out in the last couple of days, and he was talking about rust prevention in workshops, and he mentioned using a mixture of water and sodium hydroxide to wet down surfaces like tables on bandsaws, drill presses and so on. And his view was that the alkaline solution sits on the surface there and it won't allow the steel to rust. Now I'm actually going to try it. I bought a new spray bottle. I'm going to make up a weak solution of sodium hydroxide, and I'm just going to spray that on, wipe it down with a rag, just swab it and see if that works. But yeah, it sort of makes sense, so I'm going to try it out and I'll report back to you. These are the parts I've already powder coated. So this is the sheet metal headstock cover, and I did go ahead and fill the gaps where the joints are with JB Weld, and then I powder coated over that. And this is a wrinkle black finish, which has got a fairly heavy texture, and the texture is good for disguising any little gaps and so on, or dents and blemishes in the surface. But I think that's turned out really nicely. And this is the headstock here, which is partially assembled at this point. And this was a textured powder coat. I think it was called Silver Vein. And we're going sort of a black and silver theme with this one. And when I do all of the anodizing, that will be done in a black dye as well, except for the boxway guides that the headstock slides on. They're just going to be plain anodized and not dyed, and that's really to just harden up the surface of the aluminium and make it slide a bit better. So yeah, get the anodizing done and I'll get it all assembled, and you will see it working in the next video. So these parts here were the brass dust covers that go on the top of the headstock, covering the top bearing, and this is for the bottom bearing here. And I've done these with a zinc plate finish and then a black chromate over that. And it's just purely decorative. If I left it as plain brass, it will eventually oxidize and sort of go dark brown, but this stuff here lasts forever, and it just gives it that nice sort of satin black finish which will match the rest of the parts on Threadexpress. Okay, that's all for today's episode. Thank you for watching. There's only one more episode to go, and that's the one where I'll actually use Threadexpress on the milling machine to make some parts. So tune in for that one. And I'm going to leave you some wildlife footage today, as I normally do, so sit back and enjoy that. And I'll catch you on the next episode of Threadexpress, the last, and we'll see you then. Okay, it's Prezzo signing out for now. Cheers.